Okay, this is the next question we've got. We've got u equals 4 to the x. We want to know what x has got to be. So to get x down from being that power, we've got to take logs. So if you take logs of both sides, we have log of u is log of 4 to the power of x. Now, what can we do if we have a power inside a log? Bring it in front, yeah. So we can get log of u equals x lots of log of 4. Log of 4 is just a number, so I can rearrange that, bring the log of 4 underneath the log of u, so I get x is log of u divided by log of 4.
Is log of 4 and natural log of 4 the same thing?
No, it has to be the ln version.
Why is that the ln?
Well, because we're going to be using...
both sides, wouldn't it just matter? Because
yeah, but when you... Okay, we'll have a look in the rest of this question, but normally in anything to do with calculus or differentiating, you use the log to the base e, because that's a special one. When you differentiate log e to the x, you actually get e to the x, and it doesn't work if you had 10 to the x. So you should really be using the ln version of logs. Remember, log of 4 is just a number, and it might even be easier to write that down as 1 over log of 4 times by log of u, because in a minute you're going to differentiate that, because we need dx du. What do you get if you differentiate log of u? 1 over u. And if you're timesing it by a number, which we are here, the derivative of that is the 1 over u times by the number that we were timesing a log of u by. So that's what you get for the dx du. So our next line, to get what dx is, I will just move that du up the top. So I've got 1 over log 4 times by u du. That's what my dx is equal to. This is a question with limits, so I need to change my x's into u's. X is 0 and 3. U is 4 to the power of x. 4 to the power of 0 is 1. 4 to the power of 3 is 64. So, now I've done all that, I can carry on working on my integral. It's going from 1 to 64. 4 to the x is u. On the bottom, 4 to the x is u, plus 1. And dx is 1 over log of 4 times by u du. Always at this point hoping something useful is happening. It is. I can get rid of those. Log of 4 is just a number, so I can put that in front of the integral sign. So I'm getting 1 over log of 4, the integral from 1 to 64, and all I'm left with here now is a 1 and a u plus 1 du. What is the integral of 1 over u plus 1? Yeah, that's right, natural log of u plus 1. Okay. Again here, that's the derivative of the bottom, so the answer will be log of the bottom. So log of u plus 1 is what I get from doing the integral. I've got to evaluate that 1 and 64, and I've got to times the whole thing by 1 over log of 4. So, in the square brackets I'm going to have log of 65, that's 64 plus 1. Take away log of 1 plus 1, which is 2, and that is all being divided by log of 4. Nothing wrong with that answer, that's a perfectly acceptable answer. The mark scheme I've got here has changed that to be log of 65 over 2, and then they've written all divided by log 4. It's all the same thing. But basically, if you can get down to that, that is a perfectly good answer. And just looking at the actual wording of that question, again, it said an exact value, so it's not going to want a decimal. It is going to want it in logs at some point. Can I just go through where the marks are, and then I'll take the question. So for that question, that was out of 6 marks. They gave, let's have a look, 2 marks for all this preparatory sort of work up to here. So everything here, they have sort of given 2 marks. for that preparatory work. They have then given another 2 marks if you have got to this line here. That will include that limit change. And then they have given 2 marks for the processing and the final answers. So they've given 6 marks altogether for that question.